Hello, everyone. Good evening. Buenas tardes. So my name is Sam. I'm the co-founder and CTO at OSO. And tonight I'm going to be talking about authorization. So a little bit of background on me and OSO. Yes, it's OSO is Spanish for bear. So my co-founder and I, we met up almost 3 years ago, and we sort of had this idea, this shared vision around making security easier and more approachable for developers. And that path has kind of led us into this area of authorization, which is something that we found is just not really well addressed by the information that exists out there or the tooling that exists out there today. And so that's what I'm hoping to address a little bit tonight, is to just sort of give you some core principles, best practices, and show you some tooling in the form of OSO about how to approach authorization. And this will be specifically in the context of Python and SQL Alchemy, in at least for the demo piece. But the rest of it is kind of information and knowledge that you can take to any language, framework, application, whatever you have. So here's my sort of short outline. I'm going to kind of go first cover the foundations. What is authentication? What is authorization? Those two terms often get confused, so I just want to kind of lay them out for people. And then next, I'm going to start talking about some of the patterns that exist to make authorization a little bit more of a structured problem, a little bit less of just a ad hoc, do whatever you want kind of thing. And then finally, we're going to get to the sort of fun demo piece of this, where I'm going to show you how this can look in a Flask SQL Alchemy app, and how OSO can make some of this authorization stuff a little bit less painful. So to start off with, authentication, right? So you've probably encountered this across many, many different web applications. The example I have here is GitHub. So you go to GitHub, it maybe pops up with this login form on the left, asks you for a username and password. This process that you're going through here, where you prove who you are, is authentication. So I provide, the passwords and maybe the two-factor, SMS number or something for Sam Scott 89, and I've authenticated that is who I am, right? So this is authentication. Who are you? Authorization, on the other hand, is not always as obvious. So here are two different URLs in GitHub. And again, the only way I could really show this was by finding URLs that would exhibit some authorization. So it's a little bit more kind of buried in the app. But so I have two different URLs. One to list the teams for the OSO HQ organization, and the other to list the teams for the SQL Alchemy organization on GitHub. When I visit the first link, it's fine. It's happily showing me, a bunch of teams. We've got our Eng team at OSO. But on the other hand, the SQL Alchemy one, I get this, it just redirects me back to the organizations page. And instead I get this little, what do they call that? Like a toast or something, the little notification that says, you're not a member of any teams in this organization. And so what's happened here is authorization. So GitHub has decided, based on who I am, Sam Scott 89, what I'm allowed to see in this app. And so they said, oh, Sam, you are you're a member of the OSO HQ organization. You can see the teams. You're, in this case, I'm not a member of any teams in SQL Alchemy, so I'm not allowed to see anything. So again, so authentication, right? Who you are. Authorization is what are you allowed to do, what are you allowed to see, things like that. So the thing around authorization is that it's kind of somewhat of a blurry topic. It's very, very interwoven with like your core application, how your application works. So it's not always easy to just like handle it separately from the rest of your app like you might do with authentication. And so what this often leads to is people building up authorization and permissions codes in a bit of an ad hoc manner. So they don't necessarily have a structure in mind, or a particular framework they want to apply, and they just kind of accrue bits and pieces of code. Now, there's absolutely no judgment here on the code that's been used. Like, it's fulfilling the purpose, it does what it needs to. That's great, but it can just be hard to maintain. And that's kind of one of the things I want to address here tonight, is just show you there exists a better path that you can get around just like how to approach authorization. So the first piece of that is on enforcement, right? And so this is kind of, I think of this as just asking the right question in the first place. And so I think that question is, is the user allowed to perform action on resource? So I've kind of highlighted these key terms here, user, action, resource. And that kind of like triple is really the core of authorization. Can this user perform this action on this resource? So on the previous page, right, it was, is Sam Scott 89, the user Sam Scott 89 allowed to read the teams for the O2HQ organization or for the SQL Alchemy organization? And, again, this triple can cover pretty much everything that you can think that you need to do inside an application, right? Am I allowed to create a new repository? Am I allowed to open an issue? Am I allowed to close an issue? Am I allowed to edit a comment? All of these things come back into this format of like, is the user allowed to do this action on this resource? So the resource here might be an organization, right? Reading teams in an org. It might be a repository, pushing and pulling, editing the code. It could be an issue, opening an issue. And again, the action is those, the verbs are just using open, read, push, pull, create, all those kind of things. Those are actions. And so this triple is kind of like piece one. It's just like, what is the question you're asking that you want to do authorization over? And I think of this about it as enforcement, because generally what you do is you ask this question, do some authorization logic, and based on the answer, you're going to then decide what to do with it. So that might be, like we saw before, redirecting the user back to a page that says, you can't see this. It might be returning a particular HTTP status code. So that is your kind of like enforcement piece. Pattern 2 that I want to talk about is roles. And really, roles here is a kind of specific way of making that decision on like basically answering that question, right? Can Sam do this thing? So one approach to answer that is through roles. So you might also see roles referred to by this acronym of RBAC, role-based access control. I tend to try and avoid acronyms, so I'll mostly just speak about roles, but these are kind of one and the same thing. And basically what this does is it takes that question, what is the user allowed to do? But whereas like before any of this is just an entirely open question. I have, all of my users, I have all of the things, and like, how am I supposed to decide who can do what, right? It's just a completely open question. So what roles does is says, well, all these users aren't really the same, right? Actually, the majority of these are regular members, and some smaller number of them are admins. And by like doing this classification, I can basically forget about just how many users I had. So it could be 10,000, 10 million members. Like, it doesn't really matter. They all just have this member role to me, because now I decide what they can do just based on that attribute, that role they have. So I might say, members can read and write, admins can additionally delete. And so again, thinking about in like the GitHub example, you might have one of these roles inside the organization, and that role determines whether you're allowed to see some teams, maybe create a new team, things like that. Here is an example of, it's kind of a slice of a roles table from GitLab. So GitLab is sort of much like GitHub. It's also used for maintaining, collaborating source code, but it has like a ton of things beyond that as well. You can manage CI pipelines. You can deploy and maintain your Kubernetes infrastructure, and even more things that I'm blanking right now. But I think one of the really cool things to see is that despite this like huge product of GitLab, they still just have like these 5 roles: guest, reporter, developer, maintainer, and owner. And I think what's really great about this is it actually gives you a really good example, in my opinion, of what roles can do when they're like leveraged properly. So they have like very few of them, but in particular, like the names of these are, I would say, kind of intuitive, right? So if I am, on a project and someone has given me the developer role, I would probably expect that I could, develop the code. So maybe I can like push and pull changes, or at least like open PRs, and like, part of, I expect my responsibilities is some amount of like, editing that code. Whereas if I'm a guest, right, guests, I'm unlikely that a guest is going to come into my repository and start deleting issues and pushing new code and things like that. You're like, guest is probably read-only. Oh, reporter. Yeah, that sounds like someone who can report things. So maybe they are able to open issues. They maybe have a certain amount of visibility. And so this really shows you like how like one of the ways that roles can be very powerful as an authorization pattern is that it kind of gives you this like intuitive way to communicate to your end users like what things they should expect to be able to do in an application. But I think it kind of depends on you trying to have like a small number of those, because if there's hundreds of these, you're kind of like wading through a table and trying to go through these like checkboxes, like finding out which one I have, then it can get pretty complex. Okay, so what about OSO? What is OSO? So OSO is an open source authorization system, and it's specifically made for developers building applications. And I'd say primarily our focus at the moment is on B2B applications, so business to business. So something like GitHub, I think, is an interesting example. It kind of crosses between a bit of both. You can use it personally, but also as a company. But that has that that concept of like having an organization is kind of like one of the main things that we'd expect to see of people using OSO. So the main piece of OSO is that it's a library, and this is your library for doing that enforcement and doing that like authorization logic. So the main thing is it helps you make those decisions and effectively add those to your application so that you can properly authorize what's happening in your app. So that's kind of piece one. Now, this library is available across multiple different languages. Obviously tonight was mostly speaking about Python, but we actually, OSO can actually be used across, a range of the other languages from, Java to Go, for example. Now these are all available. Again, it's like open source. These are all available just through regular package managers. Pip install OSO, you're good to go. Now the second piece of OSO is what we call like batteries included. So the library itself, it gives you this this kind of like framework, this like structured approach to authorization. And then what batteries included does is we basically said we're going to take all the best practices, everything that we think you should know or use to do authorization, and we'll just like make that available in the library. So I'm going to be like giving you a specific demo on this later around batteries for roles. So it's like if you need roles, here you go. Just go and put this into your app. So there's kind of like two main pieces to OSO, like the kind of like two sides of this interface for how you actually go about using it. So one piece is the policy. So that's what you see at the top here. And this is how you express the authorization logic, like what do I want to be allowed, what I want to happen, who should be allowed to do what in my application. And I'm going to express that in like these logical rules. So it's kind of like abstract logic, that looks somewhat like methods. It's like piece one. The second piece is like the library itself that you add to your app that does that enforcement. It uses that interface of user action and resource. So you basically call this method OSO is allowed, and it takes in user read organization, things like that. So we kind of have this this kind of vision in our heads that sort of OSO becomes to authorization something like as SQL Alchemy is to SQL. So it really just gives you this like structured approach, this principled approach to how you'd go about authorization in your app, much like SQL Alchemy would do for SQL, and it'll give you a way to to make queries, to manage sessions, to model your data, to do migrations. Like all of this kind of stuff is inside like the SQL Alchemy project. Similarly, that's what we try and give you for authorization. So now I'm going to go into a demo, and I'm going to show you kind of a few things. One, just sort of like a practical sense of, maybe a more concrete sense of everything I've spoken about up to now around like, what does like authorization look like in an app, but also like how how this could look if you use something like OSO. So it's kind of two pieces. I'll just kind of go through again those like OSO basics, like build it up again, show you what's happening there, and then I'm going to dive into this Git Club application, which is We've mentioned GitHub already a bunch tonight. That's the same thing I'm going to be kind of like showing you is in a GitHub clone application, like how some of these authorization patterns look. Okay, so not this one. So just to remind you, right? So OSA is available in multiple different languages. So for example, there's like Python, there's Java, there's Ruby, there's like Node.js, JavaScript, TypeScript, basically. We also have Go support and Rust support, and that looks like the set. And basically all of these, they use this like pretty much one of the same enforcement interface where you write oso is allowed, and it takes in that triple, the user, the action, and the resource. And basically, like I was saying, pretty much all authorization decisions can be framed in this way with that like 3 inputs. And so what we've said is like, fine, we'll give you that as an API, and you should just like adhere to that, and you'll be able to ask your questions in that format. And it's going to be the same across like multiple languages, modulo, changing things for the like idiomatic casing, so in Java it's camel case is allowed. It's going to be the same for JavaScript. Ruby it's going to be this kind of like allowed question mark style thing, and so on, right? But ultimately it's like the same interface. And the idea is we're kind of like trying to get you to think about authorization like in that, just always in that thing, like can the user do this action on this resource? So for example, suppose you're in your Flask application or something like that. I have like a little pseudocode web app method here, create project that takes in some data, right? So maybe this is my app code. It takes in some dictionary fields. It creates a project and saves it and returns the project. So if I want to make sure that this this creation was authorized, I'm going to go ahead and use that same interface, right? So is allowed. Probably going to get the user from from the context or from some global session, but basically the user allowed to create this project. And I guess we need an if statement here. So maybe it's like if the user is not allowed to create a project, then we're going to return let's say a 403 unauthorized. And so this is kind of the cool thing, is like you just have this like one interface that you need to add to your application code to do authorization, and this will be the same across like all the methods you have and like everywhere throughout your app. Okay, so that's kind of like piece one, is this interface, but you may be thinking pretty correctly, right? Like that is literally just a method interface. Like surely anybody could have come up with that and use that, and they'd be have the same thing, which is right. So in some ways the kind of core thing we're providing isn't just this interface, but it's actually enabling you to use this interface by what backs it. And the thing that backs it is the policy language. So, oops, spoilers. Okay. So we purpose-built this this language specifically for authorization, and it's called Polar. And it's kind of a couple of like core pieces of this to understand that's like why it's used for, like how it can be used for authorization. So number one is it's a declarative logic-based language. And so this means like instead of you kind of like it like going through and executing the code, you sort of just tell it like, here's what I want my end state to be. Like here is the authorization logic that I want to enforce. Also, you figure out like how you do it. So that's the declarative piece. You kind of interact with it by writing a series of rules. So you're telling it like what you want to happen. And the kind of like final really cool piece of this is that it like all takes in application data. So you'll see this in a second. So, much to mirror, we have this OSO is allowed method. To mirror that, the kind of like core entry point to an OSO policy is an allow rule. So you write this, it kind of looks like a method call. It kind of looks like Python methods. It's pretty close syntactically to that. So you kind of write user, action, resource, but now you write if, because this rule is saying a user is allowed to perform this action on this resource if these following conditions are true. So maybe, you know, I said before, our action would be create, and our resource is a project. There's a couple of things happening here I'll come back to in a second. But yeah, so maybe a user is allowed to create this project, and maybe we just have like some simple condition like the user is admin. Okay, so there's a few things happening here. Number one is like these inputs, user, create, and project, they're coming straight from Python, right? Passing in some user object, the string create, and some project. These are getting matched against this rule. So the user is, you know, the user is the user. The string create is being matched with this second argument. And we're saying that, you know, for this rule applies if the third input is a project. Because we can write multiple of these. I could have one for a project. I could also have one for a, I don't know, a document or something. And this is like where the declarative piece is coming. So you tell it like, user is allowed to create a project if the user is admin, or user is allowed to create a document. Maybe this is just like unconditionally true. And because it's declarative, you don't need to tell us like, oh, do this allow and then do this allow. Like we'll figure out that piece for you. And so this, so that's kind of like the declarative and rules piece. And the application data piece is where that like Python user or that Python project is being evaluated inside this Polar file, right? So it's not, you know, we're not in Python anymore, we're inside the Polar language. But we're able to do things like compare what type the input is. Is it a project or a document? And we're also able to do things like this is admin thing here would be like reading attributes from the Python class. Right, so in particular, you know, maybe we have, you know, the user object and it's got a like is admin field or something like that. You know, this is what we're reading here when we do user.isAdmin, even though it's like in this other language. And so the really cool thing is here you get to express your authorization logic like separately from your app, but using the app data. Okay, so that's like the core, you know, the core pieces of OSO. And what I'm going to do now is show you how this all like fits together in as kind of a more substantial and a more real looking application. So here I have my beautifully designed, no expenses spared, incredibly polished web app called Git Club. We're going for sort of like a 2020s brutalist, minimalist style web app here. It's very, very popular these days. So you see my Git Club app. It's a GitHub clone. I'm currently logged in as john@beatles.com, and I can navigate through the app. You know, basically like the same stuff you can do in GitHub. Just I think our interface is a bit cleaner. So I can see organizations. I have the Beatles org. Inside the Beatles, I've got some crucial information about the billing address, the other members of my org. I can invite members. I also have repositories, and so inside Abbey Road, I then also have some issues. So, right, you know, I've got like organizations, repositories, issues. These are all like nested within each other. Users can potentially belong to many orgs. What was the other one I had? So admin, admin.com. Nope, forgotten now. What was I? Maybe I haven't added them yet. Oh yeah, admin hasn't been added to anything yet. Never mind. So yeah, okay, so I have like my core data structures here, right? And this like somewhat simple application though is actually already capturing a lot of the complexity you often see in like most, I would say most B2B web apps. So we have organizations, users can belong to them, they can have roles in those orgs, and then you have like things nested within the org. So like a repository, you know, it's kind of like a project, it like groups a bunch of other stuff. So, you know, like who's allowed to see what repositories? Well, they might be, you know, in the organization, or they might be like directly assigned to that repository, and then you can see the issues within that project and so on and so on. So we actually have like quite a lot of the core building blocks, the core pieces of, you know, of a relatively complex web app. So let's see what this looks like in the SQL Alchemy side of things. So I guess I should have said, right, this app has been built with Flask and SQL Alchemy. So Flask for like the web app piece, SQL Alchemy for our database models and integrations, things like that. And it's has the things you might sort of expect to see in a SQL Alchemy project. So for example, and I'll kind of explain a bit of this for those who aren't familiar with SQL Alchemy. So SQL Alchemy gives you this way to define your data models and your database schemas in particular via writing Python classes. That's like one piece of SQL Alchemy. So for example, here I define the org class and the corresponding orgs table. This is going to be created in my like SQL Alchemy database. And I can define the columns on that organization. So an org has an ID, a name, a billing address, things like that. But this is still just a regular Python class effectively. So I can also define methods on it. Like I had this lovely helper method that basically returns this as a little JSON blob dictionary kind of thing. So I have org and user, repository, things like that. So there's nothing like overly, there's like nothing too special going on here. This is just like the core thing you might see in like any SQL Alchemy app. We have, as I said, we have like these nested relationships where repositories belong to orgs and things like that. So the I guess the other piece is in our web app itself. So for example, let's look at inside creating an organization. So we have our Flask like web app handler here. It takes in that request for like a JSON blob of data to create an organization. And you can see we're just using this like little helper permission here, check permission. This is just like wrapping that little also is allowed thing to say, can the current user perform this action on this resource? So can this user create an organization? And like, this is pretty much it. We're basically done. There's one other kind of interesting piece, which is something we've done in particular for SQL Alchemy, just to make it a little bit easier to use, which has added this extra decorator here, which allows us to do authorization over all the like database transactions and things like that. Yeah. Okay, so that's kind of like the core piece of my app. So let's talk about like authorization. So as I mentioned, right, like we have orgs and repositories, and we might want to say who can do what to, organizations or repositories, and kind of like I mentioned, maybe you can be directly in a repository or an org. So let's have a look at that. So in this file here, in this polar policy, I have the entire authorization model for this whole app, and you can see it's sort of just short of 50 lines here. And this is like a full, pretty complex authorization model, and it's like a lot of it's been powered by some of these like built-in OSO batteries. So I'm going to talk through this one in particular that we're using to do those like organization level roles. And I'm going to talk through it piece by piece. So let me just comment out some so I can walk through this more line by line. So I'm saying up here, I'm declaring, right, it's still declarative. I'm declaring that I have a resource. The type is organization. I'm going to give it a name org so I can reference it elsewhere. And my organization is going to have two things on it. It's going to have some actions and some roles. So the actions, these are the things that I can, these are the actions I can perform on the resource, on the organization. So going back to user perform an action on a resource, you can read an organization, you can create repositories, you can like assign roles and things like that. So these are all the actions you can do on an organization in this app. Next thing I want to do is define the roles that can exist on an org, right? So in my GitLab example, we had like guest, developer, maintainer, owner, things like that. In this one, I'm going to have one called member. So my org member has a list of associated permissions. So these correspond to those actions. These are the things that a organization member is allowed to do in the app. They can read, they can list repos, they can list role assignments. And so remember, this is like any user who has the org member role is now allowed to do those things. So that's kind of one piece. I might also have an organization owner. Now they have additional permissions like creating repositories, creating role assignments. I don't want to have to like repeat all the things that member can do because owners can do whatever members can do. And that's where this implies comes in. So I say an org owner implies org member. Basically, this bit means that whatever a member can do, an owner can do. And that's sort of that's about it. That's like all it takes to have like a full role-based access control model using OSO. In the background, we're going to handle the logic and the data models and things like that for you. And it really allows you to go pretty sophisticated in your like authorization setup. So there's other piece here that I haven't spoken about yet, where I'm implying repo read and repo admin. So basically, we, and this is how it works in say GitHub and GitLab. You can have a role or an organization. You can be an org member, but you can also be like directly assigned some role or some permission level on a repository directly. So down here, I also have my repository resource with actions and with roles, and I've got admin, read and write as my three roles for repository. Now the really cool thing though is like, if you use GitHub, if you get added to an organization, you don't need to then, someone doesn't need to go through and add you to every single repository, like, oh, and you're a member on this one, a member on this one, a member on this one, and so on and so on. Often you just get a role because you're already in the organization. There's like a default role assignment. And so that's what we have here in this additional implies. So an org owner implies that you're an org member, but it also implies that you're a repository admin for any repository that belongs to the organization. And so like the final piece here is, how do we know what belonging means really in this app? And it's this tiny little piece of logic here on line 19 and 20, where we basically say, hey, this concept of like parent-child relationships, it's so common that we're going to just give you a structured way to use these. So just tell us you have a parent-child relationship. I have repositories, they have a parent organization, and you resolve this by checking these fields, say on the SQL Alchemy model, right? This is like comparing the columns. And like with that in place, I'm now done. I can now resolve logic which says like, you can, are you allowed to close an issue? It's like, well, you can close the issue if you have maybe actually we have create issues. Let's just say, let's add close issue here, right? So maybe you're allowed to close an issue and the issue belongs to a repository. So it's again, another parent child. An issue belongs to a parent repository. To close an issue, you need to have the repo write role. Well, you can have the repo write role if you have that directly, or if you have through the parent-child relationship a particular role on the parent organization. So you must have the, well, actually in this case, it'd be a org owner implies repo admin. Repo admin implies repo read. Repo read has the close issue permission. And through that, you're allowed to close this issue that belongs to on the repository. And so I think like hopefully what I'm showing here is like there's kind of structures and patterns that we're all kind of just like giving you a guideline and a framework to apply. And it turns it from being this like head scratching, like how could I, I've got to try and cover all these use cases and I've got to cover it in a million places, to like, let's look at the code. Here is the entirety of my like reading an issue code. I'm just saying for this session, you need to have read permission on the issue model. I'm going to use my regular like SQL Alchemy session to fetch it. And the permission is going to go through that crazy logic I just showed you, and it's all just handled in this snippet. So this is kind of the main things I'm waking up in 9 hours. These are the main things I wanted to show. Now, there's kind of like a few things I want to say. Like if this kind of thing is interesting to you at all, we would like love to like hear and talk to you, hear from you, talk to you about it, and like trying to help you work it out. But equally, like if you're not interested in like talking to OSO, you don't want to use us for whatever reason, we're actually making all this information available through a series of guides we call Authorization Academy. These are not specific to OSO. These are just like everything we've learned over the last sort of like call it 3 years, speaking to hundreds of companies and developers about the problems they face with authorization. We're just trying to capture it, much like in this talk, so that you can kind of go and build things the right way. And if you'd like to have those best practices but in a library ready to go, then here are some links that you can find out about us. So you can find out about the company also, who we are. We're sort of like partially based in New York, partially based remote. Everything I've spoken about today is open source, so you can read up about the documentation online. And we have a really, really awesome, friendly, growing community, Slack community around just authorization in general and the OSO products. And of course, you can check out the source code all online. So with that, I will finish. I hope you all enjoyed the talk, and I'd be happy to stick around and answer any questions that come up. So thank you all for listening.